Okay, next problem up is problem number 26. And on this problem, I could tell this is from section 7.4 because it's a rational function. So what I'll do here, let's see if the denominator factors in good shape. Okay, I can fix that. So, since this is x squared into x plus 1 plus x plus 1, so we have to do this on the side, and x plus 1 out, that's x squared plus 1. So hey, this is the integral of 3x squared plus 1 over x plus 1 into x squared plus 1, and we just put 1 like that, that's a over x plus 1 plus bx plus c over x squared plus 1. And we could pretty much, and don't forget you're going to have to split this up when you're done. You just did a problem like that. You could look it up. Next problem on the list, I'd like to look at number 28. This is not a traditional problem. Well, here I look at this, say, okay, well, the sign, there's that radical, that's a problem. If the radical wasn't there, that's easy. That's negative the cosine of AT divided by A, but the radical is standing in the way. Well, we know that drill by now. We've seen this enough. Let U equal the square root of AT. And before you take a derivative, since I don't see a radical AT in the denominator, I would square both sides. Then U use of a U sub, do U du equal A dt. So this becomes an integral of the sine. And this is my first substitution. That's my u. And I notice that dt is 2 over a times u du. And this is requiring integration by parts once. And you're done. So again, the purpose of these problems is not to work them out all the way. It's how do you start the problem. Of course, you're supposed to work them out all the way, but how do you start the problems? And the problems I picked, I pretty much touched on almost everything you can ever come across, except there are 81 of them. I'm not going to be able to do all the evens. I would love to. Believe me, I would. Absolute value is a troublemaker. Whether you take an derivative and antiderivative, there's only one way of simplifying this. You need to figure out where is it positive and where is it negative, and that's a bit tricky. A couple of ways you could do that. You could take y equal e to the x. Oops. Just kidding. And when you shift it 1 down, oh boy. I can't stop now. So we're going to shift the graph 1 unit down, and instead of this, we know it's going to be at 0. So we know how this works. We know that we're going to integrate from negative 1 to 0, and that's going to be negative. Well, there's an easy fix for that. Plus, from 0 to 2, this would be positive, and there it is. And you would continue on and wrap up the problem. So absolute value, there's no way around it. Either you graph it and look at the graph, or you solve it by hand, e to the x minus 1 equals 0 to figure that out. That's easy as well. And do some testing that will work. If I look at number 32, so again, I suggest that you pause these videos when you see a problem. Think about it for a minute, see if you can do it, and try to match what I'm doing, see if that matches. So in this case, I do notice if I let u equal 3 over x, I know that du is negative 3 over x squared dx. Being off there constant is a simple price to pay. So that is e to the u. And negative 1/3 du. And I should change the limits on the integral. U equal 1, I get a 3. U equal 3, I get a 1, and there it is. And now I don't have to go back to x, just finish it up. Substitute the 3 and the 1, and that's that. Or the 1 minus the 3, and that's that. (34). I glance at the problem. I'll try a u set first. Well, it doesn't work. If I let u equal cotangent, well, that's not going to give any variable. Let's just go back. Okay. Now, one thing I could do for sure, I could say that's the integral from pi over 4 to pi over 2, and I could clear the fractions. That's 1 plus 4 cosine of x over sine of x over 4 minus cosine of x over sine of x, complex fractions from 5a. That is the integral from pi over 4 to pi over 2 of sine of x plus 4 the cosine of x over 4 the sine of x minus cosine of x dx. And here I do notice, if I let u equal the denominator, guess what dx du is. Would you look at that? This is going to become the integral. This is my denominator. And guess what? This is right there. Oh boy, that's an ugly cosine. Let's fix that. That will be my du. What do you know? Magic, right? Nope, it's math. Alright, a few more to go. Pretty much I touched on everything that I want. I have about 6 problems, 6, 7 to go. I want to tackle number 36. Let's fix that. I want to get number 36, 42, 44. So let me take those up here. So I don't have to run back and forth for 7 minutes. Good. Glance at this problem. I'll try everything. Well, it's kind of like when we did identities back in the days. Remember the good old days in Math 8, trigonometry? When you were stuck in an identity and there's not much you could do, you would really multiply by the conjugate if you remember correctly. Here, I could split this up. I could say, you know what, look, this is the integral of 1 over 1 plus the cosine of x dx plus the integral of sine of x over 1 plus cosine of x dx. The reason I would do that, I could see if I let u equal this, there's the u. But there's that one standing in the way. Here I could let u equal 1 plus the cosine of x. Du is negative the sine of x dx. A very small price to pay. Here I would say that is a negative the integral. This is u du. I know how to do this part. But how about this part? Well, here, if I take 1 over 1 plus cosine of x and I multiply by the conjugate, I'll get 1 minus the cosine of x over 1 minus the cosine squared of x. And wouldn't that be 1 minus the cosine of x over sine squared of x? And that would be the integral of what? Cosecant squared of x minus, isn't that cosine over sine, cosecant of x, cotangent of x? And wouldn't that be negative cotangent of x minus cosecant of x? And there it is. Right? I could have also split this up and said let u equal the sine du will be the cosine. So, you know, negative cotangent of x minus cosecant of x minus, this is what? Natural log of u. So that's natural log of 1 plus the cosine of x plus. There it is. Again, we have a class discussion. We're going to go over this tomorrow. 42, our next class meeting. Well, this is straightforward in the sense I see a problem with a log or an inverse function. I would know that I must let u equal the inverse tangent of x, no way around it. What is wrong with me? I want this to look pretty. And du will be 1 over 1 plus x squared dx. It didn't work, that means parts. So this would be x times dx minus the integral of d du. And again, we just did one like that. If I take this part and see that's a over x plus 1 over 1 plus x squared. Again, don't forget to split this when you find a and b. And there it is. And again, if you're having a hard time with this, you could always talk about it. And where are we? 11 minutes. Okay, you know what? Let me stop this. I still have 1, 2, 3, 4, 5, 6 to go. So might as well. I don't want it to be too big. So we'll continue in.